So, what's up, children? In our previous session on Google Meet, we studied about the laws of refraction. And the second law of refraction gives us the relationship between the angle of incidence and the angle of refraction. This relationship was discovered by Snell. And according to this diagram, if I is the angle of incidence and R is the angle of refraction, then according to Snell's law of refraction of light, the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given pair of media. Media may be air and glass or air and water. And this constant is called refractive index. Okay, so we will now discuss the refractive index in detail. Okay, so today's topic is the refractive index in relation to the speed of propagation of light. So in this session we are going to study about how refractive index and the speed of light, they are related. Because speed, the light, we all know that in our previous session we have studied how light propagates with different speeds in different media. And you all know that light travels fastest in vacuum with the speed of 3 into 10 raised to power 8 meter per second. And in air, the speed of light is marginally less compared to that in vacuum. And you have studied in our previous session that the speed of light reduces considerably in glass or water, and that is why the bending of light takes place. So the value of refractive index for a given pair of media depends upon the speed of light in two media. For example, look at the diagram and consider these two media. This media is air, medium number 1, and this media is glass, medium number 2. Consider a ray of light traveling from medium 1, that is air, into the medium 2, that is glass. Okay, as shown it is in the figure. Now imagine that if V1 will be the speed of light in medium 1, that is air, and V2 is the speed of light in medium 2. Then what will be the refractive index? The refractive index of medium 2 with respect to medium 1 will be the ratio of the speed of light in medium 1 to the ratio and the speed of light in medium 2. We can represent this by this equation, n21 speed of light in medium 1 divided by speed of light in medium 2, that is V1 upon V2. Okay, so this is the refractive index of medium 2, that is glass, with respect to medium 1, that is air. Please remember this. In the same way, the refractive index of medium 1, that is if you want to calculate the refractive index of medium 1, for example here the medium 1 is air, and with respect to medium 2, then how will you calculate it? Now in the same way, now you will write n12 instead of writing n21. Speed of light medium 2 will come first, then it will be divided by speed of light in medium 1, and in this way V2 upon V1. This is reverse of the previous case. In previous case V1 upon V2 was there, and now when we are calculating the refractive index of medium 1 with respect to medium 2, then the equation will be reversed, that is V2 upon V1. Now if medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to the vacuum. I repeat, if the medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to vacuum, and this is known as absolute refractive index of the medium. It is represented by N2, simply by N2. And if, please listen carefully, if c is the speed of light in air and v is the speed of light in the medium, then the refractive index Nm is given by c upon v, that is speed of light in air and speed of light in medium. Absolute refractive index of the medium is simply known as refractive index. There is one more term, that is relative refractive index. When the light goes from one medium other than vacuum or air to another medium, then the value of refractive index is called relative refractive index. I'll explain you with the example. When the light is going from water into glass, then the value of refractive index will be relative refractive index of glass with respect to water. Okay. Now back to the absolute refractive index, where one of the medium should be vacuum or air only. So for example, the refractive index of water is 1.33. What does it mean? It means that the ratio of speed of light in air and the speed of light in water is equal to 1.33. Another example is refractive index of glass is 1.52. What does it mean? It means that the ratio of speed of light in air and the speed of light in glass is 1.52. Okay. So up till now, what we have learned is concluded in this slide. Refractive index of the medium gives an indication of light bending ability of that medium. कितनी light उस medium में bend करेगी. This is the refractive index of that medium. And we have got the three equations or three relations, N21, then N12, and simply the Nm, that is speed of light in air divided by speed of light in medium, C upon V. So you have to keep in mind all these three formulas or relations to calculate the numericals. Okay. Now look at the table where the absolute refractive index of some common material is given in the table. For example, air. The refractive index of air is 1.0003, ice 1.31, water 1.33, and the diamond. See, the diamond has the highest refractive index. Okay. Now, what does this mean? Highest refractive index. For example, if any two media are optically exactly the same, that means if both are optically same, then the light, there will be no bending occurs. No bending will occur when the light passes from one medium to another. Or in other words, if the refractive indices of the two media are equal, then there will be no bending of light rays when they pass from one medium to another. Now, what happens if a substance has a higher refractive index? For example, this diamond has highest refractive index, and a substance having higher refractive index means that it is optically denser than another substance having low refractive index. For example, the refractive index of glass. Where is glass? The refractive index of glass is 1.52 and the refractive index of water is 1.33. So, since the glass has higher refractive index than water, then so we will conclude that glass is optically denser and more bending of light rays takes place in glass than in water. So we conclude that higher the refractive index of the substance, more it will change the direction of the beam of light passing through it. Okay, so this is how we compare the refractive indices of the two media. So I hope you understood the concept of refractive index, and in the next session we will be studying about the refraction of light by spherical mirrors. Till then, have a nice day. See you soon.